Hey everyone, and welcome back to edritt. So in this interesting lecture, we are gonna study about how we can convert a decimal number to a radix R number. To be specific, in this specific lecture, we are gonna study how we can convert a decimal number into a binary number. We'll see how to convert, the integer numbers, and then I will also see how to convert the numbers which has decimal places as well in them. So before wasting our time, let's start. So first we'll try to understand these conversion through some examples. So let's say we take an example of 9, which is a decimal, which is a decimal number system. The radix r is equal to 10, and you are asked to convert it into binary. Convert to. The process is very easy. You have to write 9 something like this. Okay. You have to take the radix of the system which you want to convert. So binary, so radix, I'll say r dash is equal to 2. You have to start dividing this 9 with r dash until the division completes. So when I divide this, I'll get 2 4s are 8 and I'll get 1 as remainder. I'll put that one here. Then again when I do this, 2 2s are 4. I'll get remainder as 0. Then I'll put 2 1s are 2 and I'll get a remainder 0. And then when I again divide it, it won't be divided by anything, but there will be one remainder as 1. Now once you are done with this, you have to go in the upward direction. So when you go into the upward direction and you have to write down the number, how 1 0 0 and 1, and you have to put the radix of the updated. So this will be the binary equivalent of this decimal number. Now let's try to understand one another example. Let's take one complex example of 87 base 10, and we are asked to convert the updated radix to 2, which is binary. How we can do that? So again, I have to follow the same procedure. I'll write this 87 over here, 2 over here, 2 4s are 8, 2 3s are 6. I'll have a remainder 1, and then 2 2s are 4, 2 1s are 2, remainder 1, 2 1s are 2, 2 10s are 20, remainder 1, 2 5s are 10, remainder 0, 2 2s are 4, remainder 1, 2 1s are 2, remainder 0, 2 nothings are 0, 2 zeros are nothing, and remainder is 1. Now again, I have to go in upward direction. So this is my upward direction. What will be my binary equivalent number? That will be 1 0 1 0 1 1 1. So 1 0 1 0 1 1 1. 2. Till this point, we have only converted integer numbers. But what if the number also has decimal places? How are we gonna convert to that? That is also we'll try to see through an example. So let's take this example where this number is 0, 1, 2, 3. Okay. So you see sorry, before the decimal places, we have these digits, right? And this is base 10 number system, and we are being asked to calculate the base 2 equivalent of this. How we can approach that? So the approach here is opposite to what we were doing here. Here we were doing division. Here we have to do successive multiplication. What do I mean by successive multiplication? That is, you have to multiply with the new base to this number. So 2 into 0.123. So the value over here will be 246, 0.246. Now this 0 is something you have to put over here. Okay. And again, you have to take this 0.246 and multiply it with 2. So when you do that, 0.492, again you put 0 over here and then use this 0.492 and multiply it with 2. When you do that, you will get 0.984. 0.984. You put it here, the 0 post the decimal number, and then again use 0.984 and multiply it with 2. When you do that, you will get 1.968. Now this 1 is something you have to put over here, and then again you have to use this 968. So into 0.968 multiplied by 2, 1.936. Now this 1 is something you have to put here, and then 0.936 you have to extract out. So Z2 into 0.936, that is something you will get as 1.872, and you have to put this one over here and so on. You have to do this till we get a zero, complete zero over here. In this case, we were reading these binary bits downside up, but in this case we have to read them upside down. Okay, so we have to read it something like this. Now when you want to write the binary equivalent of this decimal number, what you have to simply write it 0.00011. Okay, so this will be 0.000111 and so on. Okay, till you get a zero. Let me try to take a simple example. So what I will do is I'll take an example of 25.05. Okay, I'll take this example 25.05. So I'll divide, and this is a decimal number system, and I'm being asked to calculate a binary equivalent of this number. So firstly, I'll divide this number into two parts. One is I'll calculate 25 base 10 separately, and I'll calculate 0.05 base 10 separately, and then I'll finally merge them. Okay. Now I know how to calculate 25 base 10. I also know how to calculate 0.05 base 10 to the binary. I'll try to do that. So 25 I'll put over here to 12, 1, 2, 6, 0, 2, 3, 0, 2, 1, 1, and then 2, 0, and 1. I'll go upside down, sorry, downside up, and it will be 1, 1, 0, 0, 1 base 2. Okay. Now I also need to convert 0.05. So what I'll do 0.05 I will multiply with 2, 0.05. That will be 0.10, and I'll take this 0 out. Then I'll multiply this 0.1 with 2, so I'll get 0.2. I'll take the 0 out. I'll multiply this 0.2 with this, I'll get 0.4. I'll take the 0 out. I'll multiply with this 0.4 with 2. I'll get zero point 0.8. Again, I'll take the 0 out. I'll multiply with this 0.8, 1.6. I'll again take this one out, and it will go so on. So the final number will be 11001.00001 and so on. So we'll take upside down in this case. Now, do you recall the previous lecture we were discussing how we can convert a binary number system into a decimal equivalent? Did we solve an example where we had, you know, we had digits pre the decimal point, or I should say after the decimal point? No, right? We didn't had decimal numbers counted over there. Now, what if I have a decimal number and I want to convert the decimal number in binary number system to decimal number system? We'll solve an example over here to understand that. So we will take a simple example, which is 1011.110. Okay. And this is base 10, and you're asked to convert this in base, sorry, this is base 10. We are asked to convert this in base 10 number system. You have to do nothing except writing it into the positional number equivalent. So write it in positional number equivalent form. Okay. So this is 1, 2, 3, sorry, this is 0. This is 1, this is 2, and this is 3. And this is 0, 1. Sorry, this will be 1, 2, and 3. Okay, I'm just defining their positions. Now look over here and see this 1 will be multiplied by 2 to the power 3. This 0 will be multiplied by 2 to the power 2 plus this 1 will be multiplied by 2 to the power 1 plus this least significant bit will be multiplied by 2 to the power 0, and then this. Now what is the position of this 1, but where, before or after the decimal? This is after the decimal, so it will be 1 multiplied by 2 to the power minus 1. So post this will be negative and pre this will be positive. Okay, now this one, 1 into 2 to the power minus 2 plus this 0 into 2 to the power minus 3. This will be 8 plus 4 plus 2, sorry, 8 plus 2 plus 1, because this one is 0. So 8 plus 2 plus 1 plus this will be 0 0.5 plus this will be 0 0.25 plus this will be 0. So this will be 11.75. This will be our answer. So this is all for this lecture. In the next lecture, we'll see how can we convert decimal number into an octal or hexadecimal format. Thank you for watching this video. Hope to see you in the next one.